Hello and welcome to another episode of Tom's Hardware, the podcast. It's April the 9th already. This year's going by so fast. I'm your host, Associate Editor Les Pounder, and with me tonight is Dan Aldred. And Dan's been on the show before with some crazy projects, and he's got an even crazier one now, which is why we've got him on, because it's nuts. So Dan, tell us all about yourself, mate.
Hi, yes, thanks for having me back again. It's a real pleasure to be here. And yes, I have made a crazy project, which you can probably see over my shoulder there in the back. For those who don't know me or haven't come across, I'm a computer science teacher. And in my spare time, I make hacks and various projects. So things like this suit that's stuck behind you.
So that suit's a little bit different to a normal suit. You're not going to go and get that off the peg from a store somewhere. This is something a bit cool. So what does it do, Dan? Come on.
Yeah, so on the face of it, you can see it's just a black boiler suit or kind of set of overalls that you might wear. But I had the idea, it was actually after I'd watched Blades of Glory, Will Ferrell movie about ice skaters. And in it, they wear a suit and it lights up. And I thought actually that'd be quite cool and quite good fun to play with. So I went out and bought 100 LEDs, thought let's stick these onto the suit, wire them up, and then write some programs.
Awesome. So that's 100 LEDs. So what type of LEDs are they?
I should have looked it up. WS211, I think it is. The NeoPixels, but it's the WS.
Oh, 2811s.
2811s. And yeah, there is 100 pixels, but actually that's a slight lie. There's actually 96 because when I was soldering the various pixels into place, I actually destroyed 4 of them. So there's actually 96, and you'll see when I show you later on, when we have a look at some of the patterns, you'll see that there's a slight side that's out. It's got 4 pixels missing. So when I was programming it, it made it even more difficult because obviously half on the left, half on the right, 50-50 is nice and easy. Yeah. But actually 96 doesn't work quite as well. So yeah, so it's actually 96 on one side is top heavy, one side's got 4 more than the other. But yeah, for argument's sake, we'll say 100 because it's easier to talk about the kind of code and the theory and the maths behind how it works.
Nice.
Martin's
in the chat. He's asking, can he borrow it in July because his daughter's getting married?
Yes, definitely.
I mean, you want to wear it, Martin? I'm sure we can get it to you somehow.
Definitely. It's got various different levels of brightness. So during the wedding, it can be quite subtle. You can have a nice, white or whatever the color theme wedding is. It could blend in, and then as the evening goes on, or the day goes on, we can change the colors, and mix it up a bit.
That's a good way. It wasn't even a proper segue, but that's a good way to get into this question. So Ziv's asking. Total power draw. So when the lights are all, sorry, LEDs are all on white, that's the brightest. That's all the red, green, blue mix. That's the brightest they can be. What's your total power draw? Do you know?
Well, it's got. I don't know off the top of my head. I tried to run it from the Raspberry Pi, but I could only get about 3 of the LEDs lit up, and I thought, okay, so I've got the 12-volt connector adapter, which is powering it.
Yeah.
But off the top of my head, I don't know what the power draw is. That's something I could look into. But yeah, I've got the 12-volt adapter powering it, so that obviously there's no issues with brightness or LEDs not lighting up or whatever.
Yeah.
I mean, and that actually, it's what I was going to say the other night when I tried it on, when I made some videos and tried it, that was one of the things I was worried about because I put it on and then I thought, right, I need to plug in the Raspberry Pi, so put the GPIO wires in, and then I thought, right, how am I going to do this? I can either put the power on and then plug in the adapter, or I can plug in the adapter and then put the power on. But of course, I was hovering over the switch, thinking, right, here we go. This is even going to electrocute me. Because obviously the material, it's a cheap kind of £20 set of overalls, probably nylon. And I was a bit worried about, static shocks and stuff. But yes, in the answer to your question, I don't have the exact figure for how much power it's drawing on full brightness, but that's something I could look at and post back in the chat or send to you, Les.
No problem. I mean, a rough guess, I'm thinking it's about 20 milliamps per LED. So there's 3 LEDs per pixel, so that's 60 milliamps. Times that by 96, and
Do it
we've
by
got a
100
very
watts.
big number. That's a lot of juice it's going to be pulling. So yeah. That's good. But we've talked about it for a while now. Can we see it running? We can see it behind you. Can we see
okay, then.
doing something?
So we'll start off with just a fairly simple one. Let's. I'm looking at the names that I called them because obviously I made the suit.
Yeah.
I made the suit and then obviously had to write the programs for it. So the first iteration, just basically everything was turned on, and you can probably see if you look. I've got to make sure I get this right. If you look on the left-hand side, you can see kind of in the middle, it jumps. It's slightly out of sync. That's where the 4 pixels are missing.
Yeah.
So where on the ends of the arm is actually a cable that connects to the next set of LEDs.
Yeah.
So there isn't LEDs all the way through. I've kind of split them up and then had to solder them back in. So as I was building it, I was obviously soldering the next set in on the arms and then writing a quick program to turn them on to make sure the connections are working. And then I was soldering the next slot in, checking the connection, etc., and so on. And yeah, so to start with, some of the programs were just basically everything turned on. But then I started actually creating them, and I was looking earlier about some of them that what I've called them. So we got things like bounce, which I have no idea what it was, but we'll have a look at this one. So yeah, I thought it's going to jump from side to side.
Okay.
And the difficulty with coding it wasn't necessarily the code, the NeoPixel code. It was the fact that all the LEDs are joined in one long string. So obviously, let's try and make this easy. So the LEDs start at the bottom on the left-hand side, and they go all the way up the left-hand side, round the back of the neck, and then back down the other side. Otherwise, if you had them separated, then they'd be going against each other. You'd have one group of LEDs going that way and another group going that way, and obviously hit in the middle, it wouldn't work. So it's actually a loop of LEDs, which means if you want 2 sides going down at the same time, you've actually got to program the opposite number, which is quite, well, I quite enjoyed it because I'm quite geeky in that sense, but it took a lot of writing down lists and stuff like that. I'm just looking at the numbers coming now. So LED 78 is actually its opposite on the right-hand side is number 16. And once you obviously know whereabouts the LEDs are, it becomes a bit easier.
Yeah.
So yeah, so those were just kind of some of the starter ones. Let's try something a bit more interesting because that's. So this is called rainbows.
Oh, nice.
That's actually it's not very bright, that one. Let's make it a little bit brighter. So let's go for half brightness. A bit better. It's a bit blurred on mine, but in all individual colors of the rainbow.
That's nice. And the camera slightly swamps it out, unfortunately. It's the nature of NeoPixels. They're so bright, the camera just can't compensate. Trust me, I've had to photograph them enough times.
Yeah, I remember that. They used to put like greaseproof paper over the top of them, or several sheets of greaseproof paper to try and diffuse them a bit more. There you go. I'll turn the. This one's called Sparkles.
Nice.
I think it was an old Raspberry Pi by Ben Nuttall, I think is. Was it Ben Nuttall when he came up with something for the Astro Pi board? We're basically just all sparkled. So I nicked that idea. And then we've got let's have a look. So we've got Light Test 2, which I think was one where we basically had everything working. Which again is, I think, here we go. Yeah, so it goes red, blue, and then just runs through everything.
Yeah.
Which is
the old test. Yeah.
Yeah. The guy saying he was going to go to the wedding. That's the one to wear.
Well, Martin's now saying he wants to borrow it for his motorbike.
Yeah, actually on the motorbike, that's amazing.
Just don't use blue whatever you do, Martin. All right.
Yeah, that's what he wants to do. It's interesting actually because now I've got the suit working in the LEDs. What I was thinking about, I wonder what sensors you could connect. So you could have things like a heartbeat sensor. And you could have something like, the faster your heartbeat, the colors change more red, or the calmer you are, kind of blue they go. And I thought, it's quite a good social interaction, isn't it? Because you could be out and then it could change color based on who you interact with. Or you could show a color depending on whether you wanted people to talk to you or ignore you, or whether you wanted company or something like that. You can make a dating outfit. If it's green and flashing, it means come and approach me and have a chat or something. But then I thought
that would be an interesting use, yeah.
But then I thought, well, you could have weather, couldn't you? So you could pull the weather data down, and if it's raining, you could have a raining animation, and you could, if it's bright sunshine, you could have yellow or something like that. This one is sci-fi red pixels, or sci-fi red, I think this one's called.
Yeah, I'm getting a very Tron Legacy vibe from that.
Yeah.
That's nice.
That's quite cool, that one. And then, go on.
So controlling all this, you've got a Raspberry Pi. Which model of Pi is it?
This is running on a Raspberry Pi 4, but only because it was sat on my shelf doing nothing. It would obviously run on previous versions. So I thought I'd just put a different program on there, but I haven't. Let's try another one.
So this is all programmed in Python, I take it?
All programmed in Python, yeah.
Awesome.
All written in Python.
Which library are you using for the NeoPixel control?
Using the Adafruit one.
Classic. Yeah. That's one I use.
It's just great because you come straight on. You can download it straight from the site, install it, and there's a kind of get started code just to give you all the outlines of how to turn an LED on and off. And once you've got one working, you can then obviously build up from there.
And a question to ask you: if you're using NeoPixels and you're using Python, you're using Adafruit software, you could use CircuitPython or MicroPython. You could also use it on a Pico. So have you tested a Pico out yet, or are you going to?
No, but that's my next thing. So I wanted to get working on the Raspberry Pi. I do have a number of Picos sat on the shelf doing nothing, and I thought, okay, if I can get it working and get the concept working, then I can move over to the Pico Pi, definitely. And that also, I was saying earlier that one of the problems at the moment is the Raspberry Pi. It's the bottom of the left leg, if you like. So what it needs to be attached to the pocket at the top, or maybe a pocket at the side. A Pico, obviously, you reduce your size much easier. It can just hide somewhere, probably within the suit. So that'll be the next iteration, is to take the code, get it working on the Pico Pi, embed it into the actual suit, and then you're completely mobile. You can move around.
Yeah, and if you get a Pico W, you've got access to the web. You can use an API. So anything like a JSON API, you can download weather data, and your suit tells you the weather. Pretty
good, yeah. Or it could forecast the weather, couldn't it? That'd be quite good. Give you the kind of, tell you what the weather's going to be like. It's like a virtual weather organic virtual forecaster. Or this is a flash pulse, this one's called. Yeah, it's a bit nasty, that one.
The camera's loving that one. It's struggling to focus.
Yeah. Okay. Let me go back to something a bit nicer. That's the one to wear when you're on your motorbike. Here we go. Right. Let's go back to something a little bit more subtle. There we go. The other thing I've got as well is I tried to make a clock out of it.
Yeah.
So I thought, right, if you draw a circle around the suit, and then you work out that obviously 12 o'clock, midnight is at the top, and 6 o'clock is at the bottom, and then you've obviously got 9 o'clock and 3 o'clock. Can you then program the LEDs to represent a different time? Now, I was saying earlier, it's supposed to have 100 LEDs, but actually it ended up with 96. So I think with 100 it would have been easier, because you could have said 25 each side, much easier. But because it was 96, it became a lot more complicated, the maths. But I did try and create a version of a clock. So I'll just I'll load that up. Probably easier to show you. Okay, so they are different colors, but the one that's moving around is the seconds.
Yeah.
And then the one on the one on this side, the two there, that's kind of that's the quarter past, and then the one at the bottom on the left is just past the 6 o'clock's at the very bottom, so that's moving up. So that's going to be the 7 o'clock. So it's saying it's 7:16 maybe, in a couple of seconds moving round.
Yeah. I'm checking my watch now, and that's about right for the UK. Yeah.
Yeah, for the UK. Yeah.
Yeah.
I had to go on.
It's interesting you talk about using lights. So I say lights, so LEDs for a clock. A story we did earlier today, a maker has created a wristwatch using a Raspberry Pi RP2040 chip, and it's all built into its own wristwatch, PCB, and it tells the time using coloured LEDs going round. And there are different colours like yours are, red, green, blue, and that's 28 millimeters wide, I think, the whole board, which is tiny. But it shows that you can use it in a boiler suit like this. You can use it in a watch. And I've got, if I haven't planned this, let me just grab it off my desk. But we had Gurgle Apps on last week, and they have a word clock. There you go.
Oh,
so they've sent me a PCB to solder up and play around with. That's Pico powered.
Yeah.
So it goes on like that. Yeah. So it shows that LEDs are not just one trick ponies. They're not just there to make it look pretty. You can do a lot of good stuff with them.
Yeah, definitely.
Just like
this code, I mean, the idea was, I was thinking, you go out, you're wearing it, and someone says, "What's the time?" You haven't got your watch, you haven't got your phone, or it's tucked in your pockets. So just look at me, look at my suit. It tells you what the time is. And it's pulling the time real time from the clock on the Raspberry Pi. So nice. It's pulling that down. As I said earlier, alluded to it, there were 100 pixels, which would have been a lot easier to work out, but there was 96. So there's a lot of maths going on, and it's not. It's a heuristic. It's not exactly, because obviously 60 and 96 doesn't really go that well, whereas 100 would have been a lot easier to work with.
It would be.
But you get the idea that it's 7 o'clock there on the left, and I think it's your left this side, and then you've obviously got the arms moving around, and as it moves towards the top, it's moving towards the top. There's because it's getting bigger. It's just going to go 18. It's actually going to start to now go down the leg towards the bottom, because the 30 is at the bottom, so 7:30 will be at the bottom.
Very cool.
Very geeky, but
well, you're known for being a geek, mate, as am I.
Right.
So we all. I mean, come on, a person who does stuff like this.
Yes.
And there you go. That's Dan's book, Raspberry Projects for Kids. So MP3 players, Minecraft, radio stuff. Yes, I've got a part in this as well, for my sins, Dan. I'm kidding. You did well with that one. But you do other books now, don't you? Now, I know you've got one for Microbit. Is that right?
Yeah, I've got Microbit, Kids Quest. So it's out in the UK. I think it came out in the States, New Zealand, Australia, etc. last month. So it's a number of coding projects aimed at kids with the Microbit. You've got things like, temperature. Well, you've got a couple of pages on getting started. You've then got temperature sensor, burglar alarm, compass, fortune teller. It's laid out really simply for kids, so they can just pick up the code, work through it step by step. I mean, I say it's for kids. It's actually quite nice for adults as well. It's very easy to get started on. Great present. Great. If you're looking to get started and you want something that's not too scary, it's good. Yeah,
definitely.
I'll show you again.
and I rate the Microbit really highly as a way to get kids interested in electronics. So, I mean, originally Raspberry Pi, you were looking at £30 for a board, and then you had to get all the gubbins to go with it. But kids generally have an iPad or a Chromebook or a cheap laptop somewhere. 10 quids for a Microbit, and the kids could do some pretty cool stuff pretty quickly. And in a classroom environment, superb.
Definitely. And the other thing as well is I like the fact that you can try different languages. So you dock it to your USB, and then you go onto the internet and you can program Python, Java. There's block languages as well you can use, which make it really, really accessible. And as I said, I was a teacher, and being able to go into a classroom and say, "Oh, here's a piece of hardware, but today we're going to use this language." Or a student says, "Oh, I'd like to learn this language." You can say, "Okay, try these projects you've already done, but try it in this language," and it's straight away you see the result. It's in your hand. and it's portable. It's battery powered, straight on the back. Take it out. Really, really impressive.
Yeah, and it also works with NeoPixels, mate. So I'm just looking at the suit and thinking, microbit version.
Yes, maybe. I'm writing that one down. So you've got Pico version and the microbit version.
Well, if you do it in MicroPython, all you got to change is just the board references.
Yes.
Most of the pins. That'd be handy.
Yeah.
So yeah, microbit is a good tool because with kids in primary school, so this is kids up to 11 in the UK, isn't it? I'm getting old and I can't remember things.
Yeah.
You could give this to them and give them the block languages to play around with, and they can just create really fast. Get them in secondary school, so 11 to, is it 18 now or 16?
18, yeah,
18 now. You can start them off with MicroPython, so blocks to start with maybe, MicroPython, and then you can say, hey, have you heard of JavaScript? And then the kids just go wild. Because I did a class years ago, and 2 kids came to me and said, I want to do this in JavaScript. And I'm like, go for it. I know nothing about JavaScript. I'm Python. But I'll help you debug it where I can. And they just ate it up. It was fantastic. They did a compass using the magnetometer. Great fun.
I mean, that's the good thing about it. All the sensors are built in. I mean, as a tool that you can give to a child or even an adult and just say, look, here it is, everything's built in, you haven't got to connect to anything, you don't have to solder anything, it's there. It works, it's absolutely brilliant. Apart from obviously the temperature sensor, when you kind of say to the kids, well, hang on a minute, it's not 25 degrees in here, what's going on? But that's a great learning tool, because then they have to think about, oh, is it because I've held it in my hand? And then you can say, well, what's the human body temperature? Do you really think you're at 25 degrees, etc.? And then they suddenly go, oh, yeah, it's because of the CPU. Yeah. And then you're like, well, why is the CPU getting so hot? And then you've got that conversation. So, as an educationalist, it's a great, piece of kit to be able to say, look, actually, let's extend our learning further rather than just we're doing a bit of coding and, we're making a temperature sensor.
But when it comes to kids learning, I'm completely agnostic. It's the right tool for the job. So whatever's right for them is the tool that they learn from. So if they're happy with microbit, great fun. If they want to do Arduino, no problem. Want to do Pi, no problem. When we did Pi Academy years ago, and I'm talking 8 years ago now, we had a tray full of microbits, Arduinos, and what else was there? Codebug, done by Andrew Robinson.
Codebugs, yes. Yeah. I remember them.
And we had them as well as the Pis, and people would mix Pi with Codebug, with microbit, etc., to create wonderful projects. So it isn't about, you must use Pi, you must use Arduino. Use whatever you want, have fun, play around. Yeah, and you can make wonderful projects like boiler suits that light up.
Yeah, and I think what you're saying earlier about, so I used Raspberry Pi because there was one stuck on the shelf, but you're right, I'm thinking, how can I adapt this now for the microbit? And part of that is the fun of actually, fulfilling that and getting it to work. But then part of that is actually, well, the microbit is smaller, and then the Pi Pico, okay, that's even smaller. And let's get it working on that as well. And then before you know it, you're kind of like, okay, this is actually now fully embeddable. The next thing is to look at the power supply. So, maybe some kind of solar power or something like that. I don't know. But kind of a solar panel pack on the back or something.
I've got an image now of you walking around with a Jackery in your hand.
Yes, yeah. Well, I'm glad. I don't know who asked the question about the power. I'm glad whoever said that, because that'd be really good, because I can probably work out once you've worked out what the power is, then we can work out, could you actually have a portable battery?
Well, 2811, 2812 will run. So these are NeoPixels now. They'll run from between 3, I think, to 6 volts. I'm going to be proven wrong here, but I know I know they're comfortable at 5 volts. So you can run them at 3 as well. You don't want as much brightness out of them, but it'll all be working at the same logic level as the Pi. Yeah, which is handy to have. You haven't going to do any voltage dividers then. Let's see, power supplies. You could run it from USB battery pack. How long it lasts, I don't know.
That's what I was thinking. USB battery pack, or a car battery. No,
no, don't do that.
No.
That's a scary lot of amps. It's also very heavy, lead acid.
Yes, yeah. There'll be a solution, or there'll be some way of doing it, and to make it fully portable.
It will have been done, and I would suggest looking at the cosplay world, because cosplayers have been integrating LEDs for decades now.
Definitely. And there's probably some lower power drawing LEDs because, this is at the moment, these are on 0.1 brightness. So, we're not even, we're a tenth of the brightness. And if you were out somewhere at night, which I assume you'd be wearing this at night time, then obviously you wouldn't need full brightness because no one will ever look at you. So you might, what I'm saying there is a less power intensive LED that wasn't as bright would probably be okay. And if we find what they are, then you've got a fully remote suit, if you like. You're not telling anymore.
Well, the two main ones for RGB, other than just standard RGB with common anode or common cathode, are WS2811 and 2812s and Dot Star, which are APA 102s, remember rightly.
Right.
There's another one that begins SK, and my brain cannot fathom what it is.
Yeah, they're the ones you mean.
But they're quite hungry for power, all of them. So you'll find something for them.
The other thing I was we will. Give me 6 months or something, then I'll say, look, here we go. I'll be wearing it, jumping around and stuff. I was going to say, I wondered what people thought about the design, because to be honest, it was the boiler suit was laid out flat on the ground, and I just literally cut them, 10 LEDs, pasted them out, and I didn't really have an idea of how to lay the configuration out. That's just pot luck that it ended up like that. I didn't know if there's any kind of better way to do it, or maybe they should have gone down or something, or maybe. I
mean, in my brain, I think it's vertical lines, and that way you've got a grid that you can plan and project to.
Yes,
and also you can do matrix code, which I'm quite biased for.
I did try and do that, if that's what you meant, as in the matrix.
Yeah.
I saw one earlier. I thought, oh, there's one called the matrix. I wonder what that does. It's called matrix test. So I don't know how good that is.
That would be cool. But no, having them in vertical lines will be really cool for that.
Oh yes, going down. Yeah.
That way you then got a way to control and create animation. So you could almost map pixels onto it to create images. So this is going a couple of levels above where we are now. It's like, this is a lot of work. But if you look at stuff like Pimoroni's LEDs, unicorns, that's it.
Galactic unicorn, isn't it, or something?
Galactics and
because when I was thinking about the clock before that, I wanted to scroll text across it, and I thought, I could scroll a message, but of course you can't build up the images on the LEDs because you haven't got, like you said, it's not in straight lines. But that was something I thought, would it be really cool if you could actually walk around and have a message scrolling? You could maybe have the message scrolling up and down. Might be a bit more difficult to read, but then you could do art or something like that, couldn't you? If you had, if each side had 100 LEDs running down in a strip, and 3 strips of 100 or something like that, then you could build up some kind of image on the main body. And actually, my brain is working overtime now. What I'm thinking is you could put a camera in the back that could then film what's behind you and then convert it to like a pixelated version. And then you've got a really bad pixelated kind of camouflage suit.
That is possible.
It could be good if it, just for the color wise, if it took an image, took a picture, read the color RGB from each pixel, and then mapped that onto the pixel color. Onto the LED color. I mean, it would be very grainy, wouldn't it? It wouldn't be low resolution, but
it'd be fun.
Cool. Yeah, but at night time that could be quite good. But then at night time you don't need to do that because it's dark anyway.
You don't see much behind you unless you're in a well-lit room. Working with pixelated graphics, have a look at Pico Graphics from Pimoroni. It's their library for using LED matrices on their boards.
Oh, is it? Okay. What's
it's got a really
graphics?
Pico Graphics,
Pico Graphics, right.
And it translates, if you give it a PNG file, it translates it into what it should be in a matrix. So in this case, a square I did it on. I did Locutus of Borg's face as a little pixel guy, and it popped on, easy peasy. I did the PyCast logo, that came on as well.
Yeah.
As long as you keep it low resolution, like 64 by 64
Yeah.
pixels, it looks fine and dandy.
That's cool. So really what version 2 wants to be is running on a Pico.
Yeah.
And then also straight lines. So forget the arms, just have artwork in the middle. You could be out and take a picture of someone and then their face appears on the LEDs or something like that.
Yeah.
You'd have to ask permission maybe, but it's all the crazy ideas we're coming up with.
Well, then we can merge it with Martin's idea for taking it to a wedding. You could be a wedding photographer, just
Yes. Yeah. Virtual photograph.
I realize this is like an apprentice business idea, isn't it? Really?
Yeah. It's crazy and it's far fetched. But then I don't know if you've seen. I want to say Volkswagen, but it must be a more prestigious brand than that. But they've got that color changing car, which is actually all pixels. All LEDs on the outside, and it just changes color as you want, and you can set the colors from the dashboard. It's crazy saying, let's take a picture and we'll change the suit, but actually, manufacturers are making their concept cars that change color to suit the surroundings they're in or the driver's preference. And
I think it was at CES this year, was it last year? There was a car driving around that did color changing.
Yeah, I can't remember the make, and there was two. There was one I saw, and it went through colors, but it was already pre-programmed. So they kind of taken, let's say, a red LED, a green LED, and they just basically mapped them onto the body of the car and then smoothed it all over so it looked nice, and then you got it. But this one I saw a couple of months ago, it was actually completely programmable and would change. You had the full spectrum of the RGB. So it wasn't just a kind of a couple of colors that faded in and out. You could have everything. And they were showing, like, if you're driving through the green pastures, then it could pick up the color and map that green onto your car. I was like, that's pretty cool.
So basically, if the Predator had a sports car, this is the car the Predator would have.
Yes. Yeah. Although this is ironic you bring up the Predator, because I was reading something on the other day, and it might have been on social media, that Jean-Claude Van Damme originally was going to play the Predator.
He did.
The Predator was red, and I was like, how have I got to this age and never known this?
Yeah. There's early video and images of Jean-Claude Van Damme jumping around in the jungle facing Arnie and the group. Yeah, and he's wearing something that looks like a red shrimp outfit.
Yeah, like a lobster.
It looks ludicrous when you compare to what we see now with the Predator, which is a terrifying creature.
Yeah, and I was wondering why was it red, but I thought, well, if you were against the green jungle background, red probably looked quite good, didn't it? Red and green showing up quite well.
I'm guessing it has to do with the 80s effects as well, because chroma key was green screen, wasn't it?
Yes, it was.
A green alien on a green jungle is not going to be easy.
No, you wouldn't see it. That's good. So I think I've got some ideas down here that version 2 might be some kind of art suit that could take a picture in real time and then map it onto the LEDs.
Why not? So you've got 6 months. You can come back on the show and you can show it off then.
Yeah.
So October 9th, roughly, come back on.
Okay.
We'll have a look.
See what it looks like.
Yeah. But I do like it. It's a cracking idea. Are you going to release the code as open source or?
Yes. So let me just change this program, because I thought it was something else, and that's a bit intense. That. Wait a minute. I don't think we want something as crazy as that. I'll also turn the brightness down as well. Here we go. Right. Yeah, so the plan is, obviously now I've got the LEDs working, I've got some code. What I'll do is make a video showing the making of it and all the fails and stuff like that, and all the burning through the suit, because obviously trying to solder onto a nylon boiler suit's not the easiest thing. And things like the wires were actually white. For some reason, I bought white wires to join all the LEDs together.
Yeah.
And of course, then I was left with this suit that looked great, but it was just full of white wires. So I had to go and spray them. But then if you're spraying them, do you spray the LEDs and cover them? So, all those kind of things are in the video. And then, so then I'll upload the code to my GitHub repository, and then from that, obviously, people can develop it and improve them and create something much better, and then go and try it on the suit.
Awesome. I look forward to seeing the video, mate.
Yeah.
All right. Well, we're nearly out of time, but I'm going to do something very quickly before we go. These arrived in the post for me the other day. So as we know, Raspberry Pi 5, it can do NVMe hard drives now for our PCIe connection. And we've tested quite a few out, but there's a problem. Not every NVMe SSD works on a Pi 5. It's very picky. So it's quite handy that Citron have sent over all of these. So 2242 and 2280 size drives between 128 and 512 gig in size. Preloaded Raspberry Pi OS. Just put them into your favorite NVMe breakout boards, be it Pimoroni's, be it Pineberry, 52 Pi, whoever you've got. And away you go. You've got it all working. So I'm going to be testing these over the next couple of weeks. I've got 6 in total, 3 of each size. So I'm going to test them all out. I'll let you know what they're like and whether or not they work fully and completely for your Pi 5. That's going to be fun. So I want to say thanks to our guest, Dan, for coming on. Bit of short notice as well. Thank you, mate. Appreciate that.
No, it's been a pleasure. It's been really good. Really enjoyed it.
Great project. I want to see more of it, and I'll keep an eye out for your YouTube video.
Yeah.
Cheers, mate. We're going to be back next week at the same time, 2 p.m. Eastern and 7 p.m. in the UK. And the whole team will be here next week. See you later.
Excellent. Thank you very much. Thank you.